Is it working or not as the audio audible? I think it is. Let me check it if it's online or not. It's streaming. Check again. Okay, it's working. So the audio is it working right now? Is the audio audible? I think it is. Let me check it again. Oh yeah, it is. Okay, it's good to go. So last week I was, talking about. Last week I was talking about how the nano banana, how does it work? How all of these models uh, really work, the image model. Now we got to understand tokens. The next part and the most basic and the foundational part is understanding tokens and how does it really interact with the user when you are asking a lot of questions to the GPT and talking long threads and sometimes it starts hallucinating. So to understand and to also understand the reason behind the hallucination of the LLMs right now is the way we interact with it. So this is an image that I generated with the nano banana. It's pretty good. I mean, you gotta do some of the minor adjustments and really gives you, nice images. So in today's video, sorry, in today's video, we will talk about what are tokens, why do tokens, every input that you will, every prompt that you will give it to the LLM, the tokens that they will calculate will have different value. Each LLM, each AI model has a different token system. So first of all, let me show you a demonstration. Here it is. Okay, here it is. So this is a little code I wrote, and then npx. I will run it. This file. So the prompt that I gave to Gemini was this random string of words. Hallucination. It's a long word, but a single word. Now the prompt input, this this prompt input tokens, this is a lot, and the output tokens is this whole lot, and the total tokens is this. But when we will use Claude with GPT, this input token, the way LLMs will understand it, you will get what I'm saying in a bit when I explain how token system works. For now, you gotta understand that each AI model has a different way of calculating tokens. For example, if I enter hello, run it, and it's taking a lot of time. It was quick right now. What happens? Okay. What is the models order? Let me try some other model. I got flash. Oh, it was same. Was flash light or flash I was using before? Let's try this one. Oh, it's the same, I think. Is it same or not? I think it is same. Oh yeah, it's not. So uh, the hello word, it is only one token. Why it is one token and that other word was 8 tokens? We will understand it in a bit. So back to these slides. So the tokens, first of all, before this image goes, you gotta understand. In LLMs, tokens means the currency of LLMs. It is the way the LLMs understand our prompt. By default, LLMs are not able to understand the text that we, for example, it will not be able to understand text or any other thing apart from tokens. So what are tokens? For example, simple word, this simple word hello will be 10 tokens. No, not 10 tokens. It's turned off somehow. Let me show it here. So the hello word, during the training of the model, it comes a lot of times during the training when they are training the LLMs. For example, it may come 10 a lot of times. So this single word is designated as one token, but a word like this, I mean, it may have some kind of meaning. Okay, even this, it may not come a lot of times. So how will LLMs able to understand it? It will try to divide this word. Even then, it may not be able to understand it. Then it will again divide it, and then it will try to make sense of these. Here, it was able to make sense of this because this word comes a lot of times in the training, but this does not. So it is going to divide this word into a lot of parts, and then it will designate it to tokens. So we were here, tokens. So tokens are the currency of LLMs. This is how they understand what you mean. And this is also the measurement of how they do the billing. And each model has its own dictionary of chunks. For example, how does a really simple flow of interacting with LLMs work? So you will give it an input, one input, okay. Here, yeah, wait. This, you gotta prompt it, and then it will go to the tokenizer. Tokenizer is the system in which each word is divided into many parts. So then the LLM, the actual transformer, this one, this right here, this, so that this transformer, which is the core working machinery, is able to understand all of the inputs that is coming into it. So it gives the input, we give the input, and then we feed it to, and then the LLM model feed it to the tokenizer, and then the real work starts. Here, for example, we wrote hello world, then it would look for the most common words that it had training on. For example, hello world is the most common used word, so it will find related words. Okay, then it will denote the tokens to it. For example, in the training, hello might have a token of one value, and world might have a value of one. So it will give two tokens. But if your word or the input has a lot of words and it does not make very much sense easily, so it will try to divide those words. It may be like, okay, hey, what are this now? We know the LLMs will give a answer to this, like, hey, what are you doing? The LLMs will try to predict it. So first the LLM will try to divide it, and then it will try to make sense of all the things that may come after that. Hey, what word, it doesn't make sense. So what is the most common word comes after what? Hey, what are you doing? Hey, what are you doing? there is a probability that, hey, what are you doing, may come a lot more than, hey, what is this, maybe. So the tokens with the most probability will be assigned, and this is how the tokens are assigned to each input. And then after the tokenizing system is done, after each word has a tokens assigned to it, then the input will be made in a box. It will be wrapped and given to the transformer in the token forms. For example, we cannot really give, we cannot really give the LLM a text. It doesn't understand that. We can't give text. So what will it give? For example, we will have a token of, for token number 15, 13. Our cat will have a token number of 12, and give will have a token number of 15, 16, and text will have a token number of 18. What it will do is it will make an array, and it will send this 13, 12, 15, and 18. This is how it will give the input to the actual machine transformer, which is going to predict or give the answer after analyzing a prompt. And then each token is calculated and the cost is calculated, how much compute does it require, and then it will formulate an answer. It will not formulate a text. What it will formulate is this. Okay, 20 is this, this, this. Okay, this is the output of the transformer after analyzing the text. After that, the decoder and the decode tokenizer will convert this into a text in a human readable form. So then we will get output. This is the raw version of the things. I was not really making it very easy, but this was a raw version. Let's now understand it in more depth. What are tokens and how do they differ across different models? Why do they differ, and how did these tokens affect cost and performance and the processing of these tokens, and how to actually improve your workflow with LLMs? First of all, we have know the tokens are the currency of LLMs. You gotta understand that each model have its own dictionary of chunks. So, for example, the word hey buddy will have different token calculations. For example, these are two words. In Gemini, it may be, you know, 4 words, but in Claude, hey buddy, in Claude, it may be 8, it may be 9, or maybe 5. It depends on how in the training of the LLMs the value is assigned to each token. It may be, this may be 4 or 1, and this may be 4, 4, or maybe vice versa. So this is simple. Now that we have understood how tokens and what tokens really are. So for example, it's like unbelievable. Sometimes one tokens, okay, that each word, now you gotta focus here, that each word which is not added to the dictionary for efficiency purposes, for example, sometimes may not be added as a word that appears a lot. I mean, it usually is. But in some of the phrases, sometimes is used in a different ways in each sentence. So it's not really default to assign it to a token. Sometimes it may be one token, and sometimes unbelievable maybe 3 tokens. Okay, I was a bit confused here. So how does this assignment of tokens to each word works? The common word which appears a lot of times, For example, hello, unbelievable, commonly used words that appears a lot of times in the training, like cat, the, function, long and weird words that do not are, are not usually used in daily conversations. They are not added to the common dictionary words, common words that hold one token. So for the LLMs to understand these kind of words, it will divide it into different parts, and then it will try to match this part into its training data. For example, this word appears in a book but only few times, but during the training it is assigned a value of somewhere in the matrix, in the vector space. So it will try to divide this word into multiple parts and then try to match that parts into the vector space, and whatever word it matches, it will give you output related to that. And now we have understood what tokens are. We gotta understand how do they really think after the token is divided, it is broken down to different parts for the transformer to work with. So how LLMs really think? This is the text input that is given to it, then it is converted into token IDs. For example, an array like this, like 12, 14, 2, and this. Then this is to convert into token IDs. I mean, each token word ID holds a value of word. It may be hello world, or maybe hey, what are you doing? Maybe here doing. This will be the way the LLM will understand the text that we will input, and then it has understood what this is. Now it will try to formulate an output. It will try to convert it into vectors so that it can keep adding new words to the response that is it is going to give. So this was the input, and now it is going to think, okay, I'm going to assign a word that has the most probability of being here. For example, I asked it, hey, what are you doing? It may ask, I am not doing anything. This will be the response after applying the transformer math and predicting the next token, and it will keep repeating the process until this does make sense. For example, it can say, okay, I am doing fine, what about you? So this is the maybe expected response. It may come to this response exactly in a few seconds, or it may, during the training, it may try to say this, I am doing a this, you know now this doesn't make sense. So during the training, it is trained so that it makes this most sense to the human readable format. This is how the token system works and how the LLMs thinks with the token system. So they don't really see words, they see numbers mapped to text chunks. That is why you know each programming language does have a different token system. For example, 10 lines of 10 lines of JavaScript may have let's say 100 tokens, and 10 lines of Haskell may have 200 tokens. Why? Because JavaScript appears more frequently in the training. It is a very commonly used language, and a lot of developers use it. But Haskell is very rare. Not everyone knows it. I'm only very into the software tech world. They know Haskell, but most probably the data that is trained on will have a lot of JavaScript data, but very less Haskell. So it will try to. So it will not try to. It will have to divide the keywords that the Haskell has with a lot more number of arrays. For example, it may have an array of, let's say 20 words of array, but it will have 40 to 50 words of array because it divided the words into more sections to make sense of the input that you have given. So how to really structure prompts? Now, we have understood that our input is what really decides the quality of the output. Because if you try to type gibberish, it is going to take a lot of tokens, you know, it is going to take a lot of compute. And if it doesn't really make sense, it will try to give, a lot of, very vague answer. So you have to structure the prompts in a more LLM friendly way. You now know that you have to type in and use the words that we most commonly used. So prompting is not really difficult. It is, people are making it more, a lot of videos like, LLM, prompt engineering and this, but it's all about using simple words in an articulate way. I mean, not really a raw thoughts. You also have to, make the prompt structure short, to the point. For example, you're going to ask it the weather. What's the weather like tomorrow in Tokyo? This is a very simple, efficient way to ask it. But if you try to over explain things or over complicate things, you will try to ask a forecast to atmospheric conditions forthcoming in the vicinity of Tokyo's metropolitan area tomorrow. It will give the same answer, it might give the same answer, but if it is more complex, if the question is more complex and you try to formulate in a more raw way in the analogies or word structure that only you understand, then your answer might not be what you expect. So LLMs are not really used to, not really used to, it's not really a way to generate truth. The LLM is a pattern recognition, kind of machine. So you have to behave it in that way. And you also have to think, yeah, here I wrote it, that LLMs are supercharged pattern machines, not judges. They great at expanding options, summarizing, or even drafting surfacing connections, but they are very lousy at generating truthful answers and long-term judgments. And you have to think in a very broad way and a very, structured way to LLM, so that you know, or you kind of guide it to a truthful answer, to map elements, to to give it some kind of feedback. You don't need to take its first answer, its first output as a source of truth, as an absolute truth. You have to keep giving it feedback, but also keep making sure that the token limit is not exceeded, so it may not also be start hallucinating. And LLM's outputs may be testable. Try to give feedback and try to iterate your input and also the output given by the given by the LLMs. And you also have to treat LLMs as power tools. You don't need to outsource your thinking that, oh, I have this problem. Okay, I'm gonna I'm gonna give it to LLM and it will try to reason it. It's a good idea if you're in a hurry, but if you're solving a very complex problem, then using the reasoning capabilities of the LLMs, it's not a good idea. If you have a lot of context, for example, the coding file may contains a lot of files. The coding files may contain a lot of states or structures that are very complex to understand. Even if the context is 1 million, it may get may add something that will create bugs in the future. So you have to test your input and also try to iterate on the output that the LLMs gives. And treating LLMs as power tools is the way to make the tasks easier and faster workflow, as you still control the blueprint of the solution that you want to implement with the safety checks rather than outsourcing your capabilities to formulate a solution to the problem. So this simple image explains it very well. LLMs are like power tools, like a power saw. If you know where to make the cut and how to perfectly keep the saw steady, you will get the precise results because it is a very powerful tool. But if you like have a cloth on your eyes very not really aligned wood, you are going to make a very messy output. It may seem like the output given by LLMs, even to your very chaotic prompts, it may seem truthful, but it does not. So LLMs are highly skilled translators who doesn't know your context. They're fluent in every language, lightning fast, and can help complex translations, but you gotta give them the correct input. They don't know. Sometimes whenever even I came across this problem, then when I'm writing the GPT, when I'm trying to solve when I'm trying to solve some problem, I try to expect, not try to expect, sometimes I expect it to fill in the blanks to my input, like it's all-knowing thing, all-knowing kind of machine, but it's not. We gotta move past that, that laziness of the brain that is hesitant to put in the correct context to the LLMs. So you gotta know that who you're trying to, what are you trying to accomplish, and what have you also tried that didn't work. Sometimes we also, keep copy pasting the same input across different models, and the answer is sometimes almost the same. But we also need to tell it that, okay, I tried this, it doesn't work. Now, what do you think? We have this, example that we have an email translate or something. Translate this to sound professional. You get technically correct, but generic corporate speak. But this improved prompt like this, translate this email to Japanese for a potential business partner in Osaka. We met once before at a conference. Tone should be respectful but warm, not overly formal. We're following up on their international software product, and you will get exactly what you need. You need to add different context. What you are expecting the answer to be. What are the different things related to this, input that you're trying to write. So this was all, in a nutshell, the way we interact, the way we interact with the LLMs, this, you know, this part, this input part is the most important to getting the correct answer. Not a correct answer, but getting a detailed and structured output rather than, entering vague sentences and making the LLM guess. There is very slippery slope. I mean, if you're you know try to if you're trying to work out some backend code or trying to implement some server logic, it may get some complex. It may get complex that is not very efficient. So you have to structure your prompt in a more articulate way that the LLM is able to understand it and give the output accordingly. And I think this understanding of the LLMs will be more crucial in the future. As you know, the tools that are coming out, for example, Google launched this Tunix post-training tool. So the understanding of tokens and the LLM system will be most crucial, as these core models like GPT-4, DeepSeek, and the Claude, or maybe some open source models like Llama, Gwen. These may become local, using your own data to tune those models and using it on personal computers, or maybe even an OS based on LLMs. It may get to that. It's very new. It's just they launched it, I think, yesterday. Yeah, I think yesterday they launched it. It's not very old. Yeah, it was yesterday. I think 2 or 3 days this week. This was this week. So you gotta understand that understanding the terminologies used in the LLMs and the generative AI space is important to getting maybe even job, maybe jobs, not more about getting or starting a business or working with LLMs, understanding the token system and how to interact and train it is the most important. So that will be all, I think.